All right, folks, today we are going to talk about something called proportional linear relationships. So let's jump right in here with our first example today. We're looking at the weight on the moon. So the weight of an object is different on Earth than it is on the moon because of gravity. So the big question we want to answer today is about how much would an object weigh on the moon if it weighs 125 pounds on Earth. So let's take a look at step number 1. We need to determine the relationship between the quantities, or in other words, we're finding our slope. So remember, we can either use our slope formula or we can do rise over run. Since we're given a graph on this one, I think it's going to be easiest to do our rise over run. So let's try that. Okay, I'm going to look at just the first 2 points. I think that's always easiest here, and make a little step like we did previously to figure out our rise and run. Now be careful because these points are not exactly on those intersections, so we need to look at the numbers that were given. So when I looked to see how much I'm going up from 0, here it is somewhere in between 150 and 200. If we look at our point with our y coordinate, it is to 165. So that is going to be our rise, is 165. Our run is how much we are going over from the origin over to our point. So that would be where we look at the x coordinate. So that would be 1,000. So that's going to go on the bottom. Okay. So here we are actually going to divide. We're going to take 165 and divide it by 1,000 to get a decimal, which would be 0.165. And we're going to use that in step number 2. So let's take a look at step number 2. It says write the equation y equals mx. Remember, m is our slope. Okay, so all we need to do here is plug in what our slope is. Okay, so we still have y equals m. This right here is actually our slope from step number 1. So that is going to be in place of m, just like this. And then we have x that follows. So we'll always still have our y and our x, unless we are solving, which we're actually going to take a look at in step number 3 in just a second here. But remember, when it says what is the equation that represents this relationship, this is the equation that we're using. So y equals 0.165x. Okay, so let's look at our last question here at the top. It says using the equation to the left or above, how much would an object weigh on the moon if it weighs 125 pounds on Earth? So again, we're going to start with that equation of y equals 0.165x. When it's asking how many pounds it would weigh on the moon if it weighs 125 pounds on Earth, we need to figure out if we're going to plug in that 125 for the x or for the y. Now we can do that by looking back up at our graph. So if I look to see here on my x-axis, that is the weight on Earth. On my y-axis, that is the weight on the moon. So I know that our weight on Earth is 125 pounds. So we're going to replace x with 125. Just like this. Okay, so when I type that into my calculator and do 0.165 times 125, we get a value of 20.625. So what that means when we look at this whole thing is so y equals 20.625. So remember, y is the weight on the moon. So this would be the pounds on the moon. So just to recap everything we did on this question, the first step was we found our slope, so our rise over run. Again, we could have found points and plugged them into our slope formula, but we just did rise over run on this question since we had a graph. Step number 2, we then used that slope from step 1, wrote it in our equation of y equals mx, and then lastly, we used that equation substituting x for 125 pounds to find how much that object would weigh on the moon. All right, let's take a look at our second example today. We are looking at rocket fuel. So it says liquid oxygen is one type of fuel used in rockets. Engineers take into consideration the weight of the liquid oxygen when planning a rocket launch. So our big question we need to answer is how could you determine the weight of liquid oxygen for any number of gallons? So let's start with step number 1. That is to find our slope between our quantities here. So remember, whenever we are given a table, the first value is always going to be x, second value is y. So x is the number of gallons, y is the weight in pounds. Okay, whenever we're given a table, it's going to be best probably to use our slope formula. So let's pull out 2 points. We're going to start with 0, 0. Okay, since that's just the first ones that we have here. Then our second point, we're going to do 1,000 and 9,527. Okay, so with our slope formula, remember it is y2 minus y1 over x2 minus x1. So let's go ahead and label these points. So this one would be my x1, y1, this would be my x2, and my y2. Okay, so let's plug those into our formulas. Remember it is y2, so we're going to start with 9,527 minus our y1, which is just 0, over x2, which is 1,000, minus our x1, which is 0. So anytime I take a number and I subtract 0, it's not changing at all. So we have 9,527 over 1,000. Let's turn that into a decimal by dividing them. When I divide, I should get 9.527. So this right here is our slope. Okay. Now let's look at step number 2. So now we want to write our equation y equals mx, where m is the slope. So we're taking our slope from step 1. We have y equals m. M is our slope of 9.527, and then x after it. That's all we need to do for step number 2. Okay, so then our last step here is to take a look at this bottom question. It says, how much does 4,500 gallons of liquid oxygen weigh? Okay, so when we look at our equation, y is the weight in pounds, x is the number of gallons of that liquid oxygen. So we're going to rewrite our equation right here, just like we have up above. Whoops, let's fix that. Okay, and then we're going to replace x with that 4,500. Okay, so go ahead and type that into your calculators. We're taking 9.527 times 4,500. When I multiply those two together, we get a value of 42871.5. Okay, and remember to add your label on here. So we're looking at how much does the liquid oxygen weigh. We are measuring that in gallons. So I'm going to add gallons onto my answer here. All right, now let's take a look at some of these practice questions for today. So our first question here, first set of questions, we're looking at the cost to install carpet as shown on the graph. Okay, you'll notice first thing that there are some numbers missing on our graph. So they do number every other line, and then they're not numbered by 1. So I would suggest first thing we start with is by filling in the numbers that are missing. So between 0 and 60, we would have 30. Between 60 and 120, we would have 90. Between 120 and 180, we would have 150. And then right next to that 180 would be 210. Okay. On our y-axis, in between 0 and 90 would be 45. In between 90 and 180 would be 135. And I'm getting these numbers just by increasing by 45 each time. So if I increase by 45 from 180, that would give me 225. And then increase another 45 from 270 would give me 315. Okay, now that we have all of our numbers filled in, that's going to make it a little bit easier to answer questions 1 through 3. The first question says, how much would it cost to carpet a room that is 30 square feet? So if we look at our graph here, 30 is down here at the bottom. It's that first line that we wrote. So I'm going to go up from 30 and then over to our cost. So we'll see that that matches up with 45. So in order to carpet a room that is 30 square feet, that would cost $45. Okay, now let's look at question number 2. How much would it cost to carpet a room that is 150 square feet? So again, if I follow up on my graph from 150, go up until I touch the line, and then go over for our cost, you'll see that it would be $225. For question number 3, it says write the equation in the form of y equals mx that represents this relationship, and then to explain what the variables represent. Okay, so we have not found our slope yet. I want to figure out how much would it cost for one item, kind of a unit right here. So there's many different ways that I could do this. We have 2 points on our line, so let's go ahead and use those. We're going to do a rise over run here to figure out what would our slope be between these 2 points. Now be careful, because remember it is not numbered by 1. So when we're going up from that bottom point, we're going up from 90 to 180. So the difference there is we are increasing by 90. When I go over, I'm going over from 60 to 120. So our run would be 60 here. So my slope is going to be 90 over 60. Okay. Now we can simplify that by dividing both the top and bottom by 30, okay? When I get that, 90 divided by 30 would give me 3, and 60 divided by 30 is 2, okay? So while that is a great number and we would normally keep it like that, because we're talking about carpet, and particularly with cost here, we're going to turn that fraction into a decimal. So if I take 3 and I divide it by 2, I get 1.5. Since we're dealing with money here, we could definitely add the 0 onto the end of that 5, but you don't have to necessarily, okay? So 1.5 is our slope, so when we write our equation, we get y equals 1.5x. Let's talk about what those variables actually mean here. So x is the amount of carpet in square feet. We know that because here on our x-axis, it says amount of carpet in square feet. For our y, that's over here on our y-axis, that's labeled with cost in dollars. So our y represents the cost, okay? So when I look at this equation, what it tells me is that it costs $1.50 per square foot of carpet in order to install it. All right, for exercises 4 through 6, we're going to use the description in the table to answer each set of questions. So it says a middle school band is selling tickets to their winter performance. Community groups have purchased their tickets in large groups. The group sales information is shown in the table. So first question says, what is the cost of one ticket? Number 5 says, what is the cost for 70 tickets? And then lastly, on number 6, write an equation in the form of y equals mx to represent the situation and explain what the variables represent. I want you guys to try this on your own first. So take a moment, pause the video, go try this on your class kick slide, and then once you've had a chance to answer questions 4, 5, and 6, come back here and let's check to see if you got it correct. Okay, hopefully you have paused the video and you tried questions 4 through 6. So now let's check to see if you were on the right track. So question number 4 asks, again, what is the cost for one ticket? So we can see from our table that for 30 tickets, it cost $225. So what we can do is we can take that 225 and divide it by the number of tickets, which was 30. When we take 225, divide it by 30, we get 7.5. But remember, let's talk about this in context. We're talking about the cost here. So we'll add a dollar sign in front and then a 0 to have our 2 decimal places. So this right here is actually our slope. We'll come back to that in just a moment. For question number 5, it asks, what is the cost for 70 tickets? So we know the cost of one ticket is $7.50, okay? So we're going to multiply that times the 70 for the 70 tickets that we're purchasing. When we do that, we get 525. Again, let's add a dollar sign in front since we're talking about cost. Lastly, number 6, we need to write the equation in the form of y equals mx to represent the situation. So like I mentioned for number 4, the cost per one ticket, that is our slope. So the 750 was our slope. That tells us how much it costs for one ticket, okay? So when we write this in our equation, we start with y equals, then we're going to have our 7.50. You don't necessarily have to write the 0, but we certainly can. Either way is fine. And then follow that with our x. So x represents the number of tickets. That was our first column in our table. Y represents the total cost for the number of tickets you are purchasing. Now that you've had a chance to see some examples, go ahead and move on and try your homework. Remember, you can always come back and rewatch this video as many times as you need to see the examples done again or review back to your notes for how to do some of these questions. Remember to try your best on the homework, and we will go over it when I am back tomorrow.